Listen up. We've got legacy machines that literally rattle the floorboards, shift changes that feel like a blindfolded relay race, and a front office that wonders why we can't just, automate our problems away. So ask yourself, why do we keep treating vintage machines like they have Wi-Fi? It's time to face the hard reality of the legacy shop floor. High-tech isn't walking through that door to save us anytime soon.
Welcome to this explainer. I'm taking off the white collar today, and we're getting our hands dirty with quantum manufacturing, the foreman's playbook. This isn't some spreadsheet theory designed in a boardroom. Oh no, this is a survival toolkit for low-tech environments, specifically looking at ammunition production today. We're dealing with ground-level tactics to get our numbers up when we literally don't have robots to do the heavy lifting for us.
Here's our standard operating procedure for today. No corporate fluff, I promise. We're covering the low-tech reality, modularity and preloading, fixing the bottom half, accountable shift handoffs, and sustaining the system. Let's get straight to work.
Section 1. The low-tech reality. Time for some structural discipline. The very first hard truth we absolutely have to accept is that $1 million automation upgrade just isn't coming. We survive through sheer discipline, which brings us to quantum manufacture. Think of it as the application of quantifiable metrics and modular planning techniques in environments with limited automation. Look, since we can't control the absolute chaos of an aging plant, we survive by controlling the quantum, the absolute smallest functional unit of our manufacturing process. We break the insurmountable down into the meticulously manageable.
Section 2, Modularity and Preloading. This is all about the human interface. To really understand how our floor operates day to day, we need to shine a spotlight on the unsung heroes out there, the shop floor coordinators. They act as the human interface between the plan and the physical execution, and they do this across 3 main pillars. First up, planning. They adapt the daily lot plans based on what components are actually ready to go, which stops bottlenecks before they even happen. Then there's queuing, positioning materials correctly to match the speed of the line to the slowest machine, making sure stations don't choke. And finally, preloading. This is organizing everything so the next shift inherits a completely prepared battlefield. Really, the coordinator is essentially the immune system of the shop floor.
Now, the absolutely crucial point here is preloading. It's our non-negotiable law on the floor. Preloading ensures each shift receives a ready start condition. No scavenging for parts, no estimating, no guessing, none of that. It guarantees that the middle shifts don't starve for materials, or on the flip side, get completely overfilled. It's really all about organizing components into traceable lots before the actual manufacturing step even begins.
Moving on to Section 3, Fixing the Bottom Half. It's time to target those underperformers.
I want to challenge a massive instinct management usually has. They look at a struggling floor and try to fix every single machine at the exact same time. But honestly, that just spreads us incredibly thin. Because here's the undeniable statistical reality of the legacy floor. At any given time, half of your machines are underperforming compared to the other half. That's just the iron law of machines. Uniform performance is a complete myth. One machine will always jam more or run just a little bit slower than the exact same model sitting right next to it.
So, instead of constantly chasing our tails, we use 5 actionable steps to actually leverage this variance. Step 1, benchmark your output in jams. Step 2, rank the machines into top and bottom halves. Step 3, and this is key, focus all your root cause efforts exclusively on that bottom half. Step 4, re-rank them later. And step 5, repeat the whole thing. We don't need a perfect plant, right? We just need to relentlessly identify and elevate the worst half for compounding gains.
And the impact of this strategy is massive. We're talking an 8 to 12% plant-wide output bump. That's what we can get just by focusing our maintenance and lubrication upgrades on the bottom 6 out of 12 vintage brass cap stamping machines. By simply upgrading the worst half, we literally lift the average of the entire plant without even touching the top performers.
Section 4. Accountable Shift Handoffs. Let's talk about human synchronization.
We've talked a lot about the machines, but let's get real about the human element for a second. Machines don't fail us nearly as often as our shift transitions do. A vintage plant runs on human synchronization, anchored by the interdependent shift model. Day, swing, and night shifts absolutely must cooperate to secure stakeholder outcomes. Day shift optimizes the output. Swing shift carries that momentum forward by focusing on consistency, and the night shift handles the light maintenance and flags early issues. It has to be a single, continuous, living ecosystem.
Now let's compare what management thinks works versus what the floor knows actually works. Management often leans into isolated shifts, starting anew each shift with minimal, often just written, communication. But that just leads to repetitive, reactive firefighting. The reality that actually scales is interdependent shifts, shared loads, ongoing real-time relays, and constantly evolving preventative problem-solving. The system supports the process, and the process secures the outcomes.
To make that interdependence a reality, we rely on the first-hour assignment policy. Basically, the incoming shift verifies inherited conditions within their very first hour on the floor. Real-time root causes are documented in a shared log, and a supervisor has to co-sign anomaly reports to prevent abuse. And critically, and I can't stress this enough, this is a non-punitive culture. We're assigning anomalies upstream to resolve issues, like a brass cap die misalignment, before they ruin a whole lot. It is entirely about issue resolution, absolutely not disciplinary blame.
And the results of this policy? Completely undeniable. 50 to 70%. That's the staggering reduction in errors we see when operating with fully interdependent shifts. When the shift closest to the defect catches it early and assigns it upstream, quality issues don't just hide for a full 8 hours, and they don't compound into a total disaster.
Section 5. Sustaining the system. Getting into mechanical discipline.
So, how do we keep all this momentum going? Well, we sustain these gains by deeply understanding manufacturing variance. It is absolutely vital for ops managers to clearly distinguish between absolute variance and external relative variance. Absolute variance means natural, predictable fluctuations based on mechanical tolerances, like a machine having slight crimp depth variations. We just have to measure and accept those. But external relative variance? Those are environmental interferences, like a component shortage or maybe wax buildup from the previous shift. Those are correctable disruptions. If you treat them the same, you're going to waste a ton of time treating a perfectly capable machine like it's fundamentally broken.
Sustaining the system also requires a cultural shield. And this is a final warning to management. The high cost of shift competition is destroying us. When management spreads stress and encourages shifts to rival each other, they end up hoarding calibrated tools just to boost isolated metrics, cannibalizing preloaded inventories, and failing to deliver a manufacture-ready setup for the incoming crew. We have to stop doing this. Cannibalizing the floor completely destroys stakeholder trust. You cannot win if you're actively sabotaging the next team. Which brings it all together with this incredibly powerful truth right from our source material. One shift may run fast, but only 3 shifts together can run far. We win by supporting the system, guys. We win with interdependent shift coordination, shared flow, and shared responsibility. Remember, your opponent isn't the next shift. Your opponent is waste, delay, and defect.
So, I leave you with this final, provocative question. Are you ready to stop competing and start compounding? It is time to completely rethink our approach to low-tech environments. Let's replace friction with trust, harness the quantifiable power of quantum manufacture, and let the discipline of your shared process drive your exponential success. Thanks so much for joining me on this explainer. I really hope this changes how you view the shop floor, and I'll catch you on the next one.